Hi, this is Maggie. In this video, we're going to document our Proverb game system with a Unified Modeling Language, or UML, sequence diagram. If you haven't seen the video in which we create the Proverb class, I'll include a link here and in the description. You'll want to understand the class involved in this interaction before we draw the diagram. Sequence diagrams are often drawn to specify how the objects in a system will implement a use case. They show the messages sent between objects in order to fulfill a use case. They can also document a series of interactions in a system that is already implemented. It can be difficult in an object-oriented system to follow the flow of control. A sequence diagram will quickly show us how control is passed between objects in response to a message. In this video, we're going to draw a relatively simple sequence diagram that documents this program called SimpleProverbClient. In the next video, we'll create a more complex one that documents the Proverb game main method. There are many tools available for drawing sequence diagrams. I'm going to use a free tool that one of my students found at app.diagrams.net, which seems to work well. I don't know what tools you're using or what will be available when you're watching this video. You don't need a tool that's specifically for drawing UML. You can draw diagrams with a painting program or with pencil and paper. When you're designing and you're just trying to figure out how a system's going to work, you may not wish to begin with a formal tool. So I'm going to choose Sequence Diagram and click Create. We're given a sort of basic diagram to start that we can edit. At the top, there are boxes that say :object in them. Each box will represent an object in the interaction. Dashed lines run from the objects to the bottom of the diagram. Those are called lifelines, and they represent time. A sequence diagram is a dynamic diagram that shows the flow of control during execution over time. So read a sequence diagram from top to bottom. Messages that are sent from one object to another are shown with labeled arrows, and return values are shown with dashed open arrows. When an object has control during execution, we draw an activation box over its lifeline. So in this basic diagram, we can see that the first instance of object is sent the dispatch message from outside the system. In response, it sends a message called dispatch to the second. The second, in response to that message, sends a message to the first called callback. Then callback finishes executing, indicated by its activation box ending and the return arrow. Then dispatch finishes executing. Now let's modify this to represent the program SimpleProverbClient. The boxes at the top should be left to right in order of their importance in the interaction. Our program starts with the static main method in the class SimpleProverbClient. We don't create an instance of the SimpleProverbClient class, so I'm going to label this as :SimpleProverbClient, indicating that there's no object, just a class. How this is done in different software packages or at different organizations might be different, but here, as long as we all understand that it means a static class and not an instance, I think we'll be fine showing the class this way. From outside the system, coming in from the left to the top of the diagram, I'll show the call to main. It is static, so I'm going to comment it with static. In the first executable line of code in main, lines 9 and 10, we're constructing an instance of the proverb object called KlingonProverb. So I'm going to edit the name of the second box in my diagram to be KlingonProverb: indicating the object, and class name. And the message from SimpleProverbClient to the proverb object is the constructor, Proverb. You can show the parameters on the call. I'm going to elide them because they're long strings. So I'll write proverb if ... if ... Klingon. Now our Klingon proverb object has control as its constructor executes. We should go look at the constructor to see if it sends any messages. We can see that it does not. It simply sets the value of the fields from parameters. So we keep the box short. No value is returned, so we won't show an arrow returning. So control is back in SimpleProverbClient main, which now creates another instance of Proverb called ElvenProverb on lines 11 and 12. That is a different object in our system from Klingon Proverb. They are both of class Proverb, but they're two separate objects. So I'm going to put a new object at the top of the diagram with a new lifeline. I'm going to open up the UML symbols in the menu and drag out a lifeline. And I'm going to label this ElvenProverb:"Proverb." Now, down under the little activation box for the Klingon Proverb constructor, I'll draw a message call from SimpleProverbClient to ElvenProverb, and I'll pass in let ... Elven. I'll draw a short box on ElvenProverb's lifeline in response. Now, back at our code, you can see we send two messages to each object from lines 15 to 18, getPrompt and getProverb, and we send the result of those calls to systemout in a printline message. Systemout is a static object of type printstream. We want to put the messages in order in our sequence diagram. We first send getPrompt to the Klingon Proverb object, and it returns the prompt. So we put an arrow from SimpleProverbClient to the Klingon Proverb object with the getPrompt message adorning it. And we'll draw a small activation box. Let's check getPrompt and see if it sends any messages. We can see it's just concatenating fields and literal strings, so it's not sending any messages to any other objects. So we can just return the prompt. I'll draw a dashed line and adorn that with prompt. Now we send that to system.out. I'll add another lifeline to the diagram and label that system.out:"printstream." We'll send the prompt to that object. That object is outside of the program we're writing, so I'm not going to dig into how it responds to the message because I want to focus on our code. That method does not return anything. So I'm going to do the same thing for the next message, which is a getProverb message sent to the Klingon Proverb object. Send the message, check the code to see if it sends any messages. It doesn't. And then return Proverb, and then send that to system.out. And now I send the same two messages, getPrompt and getProverb, to the ElvenProverb object and send the results to system.out. So let me draw that in. And that is the end of the code for main, so the end of the sequence diagram. That is a very simple sequence diagram with no conditional or looping code and only a few objects, but it's a great first diagram to get used to how these are drawn. I recommend you practice drawing this diagram yourself without looking at this solution to solidify the concepts. Maybe write another simple program with a few objects sending messages and diagram that. When you've done that, you're ready to move on.